Very good morning to all. My name is Dr.E.Purushotham. Today I am going to discuss about wave and oscillations. First of all, I am asking what is wave, what is oscillation? Do you know about wave or about oscillation? So I am going to discuss what is wave. Wave is a disturbance that transfers the energy from one location to another location through matter or space with little or no associated mass transport. You can observe on the screen. So this is you observe here, this is the disturbance point. From this point, the wave is a disturbance. The disturbance transfers the energy through matter or space from one location to another location. You can observe here. So one location to another location, it transfers the energy. You can observe this is the starting point. So wave starting point, we can observe here. This is wave is a disturbance that transfers the energy through matter or space with little or no associated mass transport. So in this wave, just the wave is a disturbance that transfers the energy through matter, but the matter is not transferred from one place to another place. The matter is not transferred from one place to another place or one location to another location. You can observe here. So this red particle, for example, it is a starting point. So it is a starting point. So it is moving from this place to same, it will reach the same point, this point. So we can observe from this figure, from this oscillation, we can observe the wave transfers the energy without transferring the matter. So this is the position of particle in an ocean wave or water wave. You can observe clearly the energy transfers from one location to another location. This is the disturbance. The disturbance transfers only energy through one location to another location, but the matter is not transferred from one location to another location. So what is oscillation? Anybody, can you tell what is oscillation? So oscillation is a repeating and periodic disturbance. It moving through medium or space. What I am saying, oscillation is a repeating periodic disturbance. But what is wave? That is the disturbance transfers the energy from one location to another location. But what is oscillation? The energy, or it is the repeating disturbance. You can clearly observe wave is a simple disturbance, but it is repeating and periodic disturbance is called oscillation. So the perfect definition I am going to give, oscillation is repeating and periodic disturbance moving through a medium or space. You can see on the screen clearly. So a repeating, here you can observe, I am giving here. So this is the right symbol. This is also, I am giving this symbol. So this is the center point. This is the center point. The wave is moving left side and also right side. You can observe clearly. It is repeating and periodic disturbance moving through the medium. You can observe clearly here. This is the oscillating wave, that is electromagnetic wave, example of oscillation. You can observe here, this is the center point. This from center point to left side and also right side, it is moving. This is the electromagnetic wave oscillation. A repeating and periodic disturbance moving through a medium or space from one location to another location is called oscillation. But wave, that is a disturbance, It transfers the energy from one location to another location. But oscillation, that is repeating and periodic disturbance, both are disturbance. But what is the main difference? Oscillation is repeating and periodic disturbance, but wave simple disturbance that transfers the energy from one location to another location. What are the examples of oscillations? You can observe on the screen, that is electromagnetic wave and also mechanical wave. So this is electromagnetic wave. You can also observe this is the mechanical wave. So you can observe that blue particle, it is moving from one location to another location. It is giving repeating and periodic disturbance. So this periodic and repeating disturbance moving the energy through medium or space. This is the example of mechanical wave. What is periodic motion? We are seeing here a repeating and periodic disturbance, but what is periodic motion? A motion which repeats itself after equal intervals of time is called periodic motion. A motion which repeats by itself after equal intervals and of that time, that particular time is called periodic motion. So what is the example of this periodic motion? So the motion of a planet around the sun, you clearly observe. For example, this is the starting point. So it is moving and it will reach after the same time of interval. You can observe clearly a motion which repeats itself after equal intervals of time, you can observe. So this is called periodic motion. So example, the motion of a planet around the sun. So what is oscillatory motion? You can observe, this is the left side, this is a tuning fork, this is the simple pendulum. To and fro are back and forth motion. You observe here in simple pendulum, you observe here, for example, from this place to this place, it is moving one side and it will come back. So this is fourth. You see, this is fourth one. So this is back one. You can observe clearly back and forth motion of a body periodically about the mean position. What is the mean position? You can observe here. So this is you observe clearly what I am saying. So this is center point. This is the equilibrium position or mean position. So this is the extreme point or end point. Extreme point or end point. From the end point, it is coming back and going forth motion of a body periodically about the mean or equilibrium position. That is called oscillatory motion or vibratory motion. So examples, first, vibration of tuning fork. You can observe clearly. This is, you observe here, this is the vibration of tuning fork. So second one, motion of a simple pendulum. Motion of this simple pendulum. So few terms in oscillatory motion. What is periodic time? You know very well. The time taken for one complete oscillation. You observe here, this is the simple pendulum, this is end point. So this is simple pendulum moving this side and coming to the same position. This is complete oscillation. You can observe here. This is the complete oscillation. Or we can take here, for example, this is the sine curve. So this is the origin. From this origin to this is half of the time period. So this is complete time period. That is one complete oscillation. The time taken for one complete oscillation, that is called periodic time or time period. It is represented by capital T. It is represented by capital T. So you can see here, so this is the equilibrium position. equilibrium position, this is the end point. This is the end point. From this equilibrium mean position to end point, or this extreme position to extreme position and coming to extreme position, that is one complete oscillation. You observe here, that is one complete oscillation. So this is the starting point. It is moving this side and coming to the same position. That is one complete oscillation. So what is frequency? What is frequency? The number of oscillations per second or the number of vibrations per second, that is called frequency. So frequency is represented by nu, that is 1 by t. So this is the number of oscillations by time. The number of vibrations per second is called frequency. Frequency SI unit 1 by time, that is a second. So we can write second inverse. So the scientist name, that is Hertz. To remember respectively that particular scientist name, we are showing here second inverse, that is equal to Hertz. Frequency, the number of oscillations per second, that is called frequency. Frequency is represented by nu. Nu is equal to 1 by t. Nu is equal to 1 by t. So displacement, what is the displacement? You can see here clearly. So this is center point or equilibrium position, mean position. From this mean position to extreme point, this is the displacement you can observe here. So what is the definition? The distance of the particle or body or an object measured along the path of motion from its mean position, or simply definition, the distance between mean position and extreme position, the distance between O and A, that is called displacement. The displacement is represented by x. What is displacement in oscillatory motion? So the distance between mean position and extreme position, or the distance between O and capital A in this figure, or the distance of the particle or body measured along the path of the motion from its mean position at a given instant, that is called displacement. So what is amplitude? What I am asking, what is amplitude? So you observe in this figure, for example, you see here this arrow symbol point to this equilibrium position point, the distance between these 2 points, this is maximum displacement. This maximum displacement is called amplitude, or simply here also we can explain, this is the maximum displacement, it is represented by capital A. Or here also from this point to this O, this equilibrium position line to this maximum value point, the distance between O and A. Here also the distance between O and A, you can observe here also. The maximum distance covered by the body on either side of the mean position. Either side of the mean, this is P, so mean position. Either side of the mean position, or simply the maximum displacement in oscillatory motion particle, that is also called amplitude. Amplitude unit, we can write, what is the unit of amplitude in CGS unit? CGS, so this is centimeter. What is in SI unit? That is meter. That is displacement, that's all. So the maximum displacement covered by the body on either side of the mean position, that is called amplitude, SHM. So what is simple harmonic motion? What is simple harmonic motion? Simply you remember a formula, A is directly proportional to minus x. A is the acceleration, x is the displacement, negative sign is the A and x opposite to each other. So what is the definition? I am going to discuss what is the definition of simple harmonic motion. The simple harmonic motion is a periodic motion about mean position in which the acceleration of the body is directly proportional to its displacement. from mean position and is always directed towards the mean position. You can see on the screen. You can see on the screen. So this is the simple pendulum. Simple pendulum. This is the center point. This is equilibrium position or mean position. So this is the end point or equilibrium point. So the simple harmonic motion is a periodic motion about mean position. You observe this is the mean position. So this is the mean position, this is the extreme position. The distance between this mean position to extreme position, it is represented by x, that is the displacement. So the displacement by time, that is velocity. Velocity by time, that is acceleration. The acceleration is directly proportional to displacement. Displacement and opposite to each other are always directed towards the mean position, that is called simple harmonic motion. So simple harmonic motion, in simple harmonic motion, just you remember this formula. So A acceleration is directly proportional to displacement. The negative sign represents that A and x opposite to each other, or it is always directed towards the mean position. That is the definition. The acceleration of oscillatory particle is directly proportional to displacement and it is always directed towards the mean position. Phenomena is called simple harmonic motion. Simply what I am saying, so this is O is the simple mean position or center point, mean position. So from mean position to extreme position, that is displacement. This displacement and acceleration both are opposite to each other. A is directly proportional to x and always directed towards the mean position. Phenomena, that is simple harmonic motion. So in this figure, you can observe this is equilibrium position. Equilibrium position. So this is maximum point. This is also maximum point. So this equilibrium position to maximum point, this is displacement x. You can observe in this figure. So this displacement is and this acceleration is opposite to each other. So A is directly proportional to x and always directed towards the mean position, that is called simple harmonic motion. You can see this is the simple harmonic motion oscillation. You can observe on the screen. You can observe on the screen. So what is the definition? The simple harmonic motion is a periodic motion about mean position in which the acceleration of the body is directly proportional to its displacement from mean position and it is always directed towards the mean position. This is the perfect definition, but simply you can remember A is directly proportional to minus x. So the acceleration of the body is directly proportional to its displacement from the mean position and also always directed towards the mean position. Phenomena is called simple harmonic motion. Simple harmonic motion. Types of simple harmonic motion. So depending on this path of motion, so it is divided into two types. Two types depending upon the path described by the body, or simply depending on path along a straight line, that is linear simple harmonic motion, or along a angular path. The body is moving around a fixed axis or fixed point, that is angular motion, angular path. Depending on this angular path, it is angular simple harmonic motion. The types of simple harmonic motion is divided into two types depending on path. So linear simple harmonic motion and angular simple harmonic motion. So what is the difference between linear and angular simple harmonic motion? You can see on the screen. So left side linear simple harmonic motion, you can see here. So right side angular simple harmonic motion. So you observe clearly, linear means along a straight line path. Right side, angular means around a fixed point or angular path you can observe. If the periodic motion of the body or particle or an object is in a straight line path, then that particular motion of the body is said to be linear simple harmonic motion. What I am saying? The motion of the particle, the periodic motion or repeating motion of the body is in a straight line path. Then the motion of the body is called linear simple harmonic motion. What are the examples of linear simple harmonic motion? So first one, vibrations of the tuning fork. Second one, vertical oscillations of a loaded spring. So one is tuning fork, another one is loaded spring. What is that linear simple harmonic motion? The periodic motion of the particle is in a straight line path. Then the motion of simple harmonic motion is called linear simple harmonic motion. If a simple harmonic motion body is moving in a straight line path, then the simple harmonic motion is called linear simple harmonic motion. Another definition we can explain what I am saying. If a simple harmonic motion particle is moving in a straight line path, then the simple harmonic motion is called linear simple harmonic motion. What is angular simple harmonic motion? If the periodic motion of the body is in angular path, then it is said to be angular simple harmonic motion. That is simple harmonic motion. You can observe on the screen. In this case, the displacement of the body is with respect to angle. Some small angle, that is angular displacement. So if the simple harmonic motion, another definition, if the simple harmonic motion of a body is in angular path, then the simple harmonic motion is called angular simple harmonic motion. Angular simple harmonic motion. What are the examples of angular simple harmonic motion? You can observe two examples. Motion of a freely suspended magnet in the earth magnetic field. Another one, oscillation of a torsional pendulum. Oscillation of a torsional pendulum. So here we can also give one question. What is the differences between linear simple harmonic motion and angular simple harmonic motion? The main differences. So first one, the linear simple harmonic motion is in a straight line path. Angular simple harmonic motion is a angular path. So these are the two examples. That is linear simple harmonic motion and angular simple harmonic motion. If the periodic motion of the body is in a straight line path, that is called linear simple harmonic motion. If the periodic motion of the body is in angular path, then it is said to be angular simple harmonic motion. So linear simple harmonic motion example you can observe on the screen. Vibrations of tuning fork. So these vibrations are moving along a straight line. You can observe here clearly. Along a straight line. You can observe here. Vibration of the tuning fork. Example, vibration of the tuning fork you can observe. So it is moving along a straight line. The periodic motion of the body is in a straight line path. So this motion is called linear simple harmonic motion. So another one you can observe here. This is the torsional pendulum. So it is moving with some angle theta m or minus theta m. So what I am saying here, you observe here, in this case the displacement of the body is with respect to angle. You can observe. So this is angle theta m. Here also this is angle theta m. That is oscillation of torsional pendulum. Oscillation of torsional pendulum. These are the main differences between linear simple harmonic motion and angular simple harmonic motion. If the periodic motion of the body is in a straight line path, then the simple harmonic motion is called linear simple harmonic motion. If the periodic motion of the body is in angular path, then the simple harmonic motion is called angular simple harmonic motion. Types of oscillations. So these are the three types. Number one is free oscillation, number two damped oscillation, and number three forced oscillations. You can see here. So types of oscillations. These types of oscillations are divided into three types. So first one you can see here on the screen. So this is definition. What is free oscillation? Free oscillation. Every particle, every body has its own natural frequency. What is natural frequency? So this is 1 by t. In general, time period t is equal to 2 pi root of L by g. So this is length. This is the acceleration due to the gravity. So here we can write this is 1 by 2 pi under root of g by L. So this is natural frequency. A body or particle which is oscillating with its own natural frequency phenomena is called free oscillations. Free oscillations. So what is damped oscillation? What is damped oscillation? If the time period increases, the displacement of oscillatory particle or amplitude of oscillatory particle decreases with respect to frictional force phenomena is called damped oscillations. So I am giving the definition with the graph. So take an x-axis time, on y-axis so displacement x. So this is the, for example, amplitude. So this amplitude value decreases. You can observe here. So time value increases, displacement x value decreases continuously due to under the consider of frictional force phenomena that is called damped oscillations. What is forced oscillation? What is the definition of this forced oscillation? I am giving only definitions. So clear discussion, free oscillation. In free oscillations, we will discuss simple oscillator. What is the equation of motion? What is the solution of simple oscillator? What are the characteristics of simple oscillator? What is a simple oscillator? If a body executing simple harmonic motion is called simple oscillator. In our previous class, in our next video, I will discuss about simple oscillator. What is forced oscillator? Third one. What is forced oscillator? If some external periodic force is applied on the body oscillates with the external periodic force phenomena is called forced oscillator. What I am saying? When we are applying some external periodic force on the body vibrates under the influence of external periodic force phenomena is called forced oscillator. These oscillations are called forced oscillations. So types of oscillations, these are three types: free oscillations, damped oscillations, and forced oscillations. I am giving here only definitions. What is free oscillation? If a body vibrating with its own natural frequency phenomena is called free oscillations. Damped oscillations definition: time increases, displacement or amplitude decreases continuously under the influence of frictional force phenomena is called damped oscillations. Forced oscillations. When we are applying some external periodic force on the body vibrates under the influence of external periodic force phenomena is called forced oscillator, and these particular oscillations are called forced oscillations. So what is free oscillations? You can see free oscillations. If no dissipative force means air resistance force, frictional force, external force, any other force. If no dissipative force, that particular forces act on oscillating body, then amplitude of the vibration remain constant for infinity time. Such oscillating body is known as ideal harmonic oscillator, and oscillations are called free oscillations. Free oscillations. If there is no dissipative force is acting on the body, that particular body total energy always constant and also amplitude always constant, this type of system is called ideal system. This type of system is called ideal system. This type of oscillator is called ideal oscillator. Ideal oscillator. What I am saying, if no dissipative force acting on the body, then the amplitude of the body vibration remains constant for the infinity time. Such type of oscillating body is known as ideal harmonic oscillator, and the oscillations are called free oscillations. Or free oscillation definition: the oscillations of the body oscillates with its own natural frequency. What is natural frequency? A body vibrates freely at its own frequency. That is called natural frequency. You can observe a body, you can observe on the screen, a body vibrates freely at its own natural frequency. Natural frequency is represented by nu. Nu is equal to 1 by 2 pi under root of G by L. So the oscillations of the body or the vibrations of the particle or the oscillations of an object oscillates with its own natural frequency phenomena is called free oscillations. Or you can observe the definition here: the oscillations of a body oscillates with its own natural frequency. When left free to itself, that oscillations are called free oscillations. The natural frequency of free oscillations is given by nu is equal to 1 by 2 pi under root of L by G. So G is the acceleration due to the gravity. Acceleration due to the gravity. So what is small l? Small l is the length. Small l is the length. The frequency will be the same as long as the pendulum does not experience resistance to its motion. Such an oscillator is called ideal oscillator. Such type of system is called ideal system. So what I am saying, there is no dissipative force acting on the body, then the frequency will be the same as long as the pendulum does not experience resistance to its motion. There is no air resistance, there is no frictional force on the body, there is no external periodic force on the body. That means if no dissipative force acting on the body, that particular oscillator is called ideal oscillator. That particular system is called ideal system. The ideal oscillator and ideal system amplitude always constant. If the amplitude of the body, vibrating body, is always constant for infinity time, that particular oscillation is also known as ideal oscillation. That particular system is also known as ideal system. The ideal system are, you observe here, the ideal systems are frictionless and energy is not dissipated away, and hence total mechanical energy and the amplitude remains constant. That is constant. What I am saying, if there is no dissipative force acting on the body, dissipative force means resistance force or frictional force or any external periodic force. There is no frictional force on the body, there is no dissipative force on the body, then the total mechanical energy means kinetic energy plus potential energy, that is total energy, that is always constant. That mechanical energy, for example, you see total energy here, so total energy is equal to half m omega square a square. So total energy is constant, so we can write total energy is directly proportional to amplitude square. So total energy is constant, amplitude also constant. What I am saying here, you clearly observe. So here total energy, that is total energy is equal to kinetic energy plus potential energy. This is half m omega square a square. So this is constant value. So we can write this is total energy is directly proportional to square of the amplitude. Square of the amplitude. So square of the amplitude, what I am saying here, so this is total energy is always constant. So total energy is always constant means amplitude also always constant. A system which is having total energy is constant and also amplitude is constant, that is ideal system. That oscillator is called ideal oscillator. What I am saying, if the oscillation of body oscillates with its own natural frequency phenomena is called free oscillations. A body vibrates freely at its own frequency, that is called natural frequency. You just remember in this natural frequency and free oscillations. A body vibrates freely at its own frequency phenomena is called natural frequency. The oscillations or vibrations of the body oscillates with its own natural frequency is called free oscillations. The free oscillating body has constant amplitude and constant mechanical energy. That particular system is called ideal system. These oscillations are called ideal oscillations. What I am saying, if there is no dissipative force acting on the body, the body mechanical energy and amplitude remains constant. So this particular oscillator is called ideal oscillator. This system is called ideal system. So what is free oscillation? I am going to close this video asking what is free oscillation. If there is no dissipative force acting on the body vibrates with its own natural frequency, that is free oscillations. So the oscillations of the body oscillates with its own natural frequency phenomena is called free oscillations.